This conference will now be recorded.
And David, you are now the presenter.
All right. Well, good evening, everybody. It's good to see everyone. I just wanted to turn my camera on briefly. I'm working from home this evening. Been teleworking quite a bit, actually, given the circumstances. Only going into the office when we have some higher impact weather. We need to increase staffing a little bit, or I'm covering shifts, which I've actually been doing quite a bit over the last couple of weeks, just with people taking some time off here and there. So anyway, I really appreciate Joe asking me to be a part of this tonight, and looking forward to presenting. And I appreciate the kind words to get started with my great presentation skills. I'm not sure if I'm going to have it tonight, but I'll do my best. It's been a long day, but I'm really happy to be here. So let me. I'll turn my webcam off. Go through. Hopefully, everybody can still see my. And at the very end, after this, we'll certainly take questions. I'm not going to. This isn't going to be extremely long, but hopefully, there's some good stuff that everybody will enjoy seeing tonight. Okay. All right. So I wanted to talk. It's pretty wide open. I thought in talking with Joe and Joe about some topics. Hurricane, we're getting right into. We're starting to approach. Really when hurricane season gets pretty active as we head into August, and I thought it would be good to kind of kick that off and talk a little bit about that, and then get into some weather related statistics and reporting things, and we'll touch base on that a little bit. But this by no means is this like a spotter training class, because I know this group is very well versed in spotter training. What it is we're looking for, reporting techniques and stuff like that. So, but that said, if anybody has any severe weather related question or anything pertaining to high impact weather, extreme weather, after this little presentation, I'll be happy to spend a few minutes talking with everyone and answering questions. So, all right. Okay, so this slide, just wanted to, many of you have seen this already. When do we climatologically see peak in the hurricane season? This is for the Atlantic and the Gulf of Mexico region, and September 10th is sort of like the day where everything sort of ramps up to it, and then eventually gradually starts to drop off. But you can see that there's definitely a noticeable spike as we head through the month of August and into September, and then even after September, heading into October, we can be quite busy. So where are we at? Well, I believe today is the 30th of July. I put an arrow on the arrow as to where we're at as we head into the 1st of August here pretty shortly. And you can see we're starting to make that ascent up the mountain, so to say. We've already had 8. Well, I guess we've had 9, the 9th named storm. I'll get into that here in just a second, but just for you record buffs, that we have never had 9 named storms this early in the season on record. So this is already been fairly active, even though for the most part there hasn't been any like extreme, like catastrophic like system just yet affect any land areas, but like as you can see, it's pretty early. So hopefully this isn't what we've seen already is not a harbinger of things to come, but we'll see. So what I'm going to get into is talk a little bit about some things that even before the season started back in April and May, tropical outlook experts and climate experts were already talking about a fairly active season, an above normal season. So many of you probably heard about that back in April and then May when NOAA released its tropical Atlantic Basin tropical prediction, if you will, with the predicted numbers, they were going above normal for the season. So there's really no surprise, I guess, that we're already active. Although seeing 9 named storms before the 1st of August, I don't think anybody really expected that. But as far as being active and above normal, we're sort of playing into that already. So one of the things, the MDR, the main development region, which is sort of north of that, it's anywhere between about maybe 7 degrees and 15 degrees north latitude in the Atlantic Basin. That's typically where a lot of these disturbances develop. And early in the season, you can certainly see some development generate in the Gulf of Mexico and then move inland or dissipate. But as we progress through like the summer and into the early fall months, that MDR is really where a lot of these longer track, potentially more significant tropical systems will develop. So over the last 100 years, you can get an idea of all the where the systems have formed and moved. So typically NOAA releases their outlooks in late May, and then it's updated in early August. So we're about a week or maybe 10 days away from NOAA sort of updating their numbers, so to say, based off of what's already happened and what is taking shape in the Atlantic Basin, this MDR region, and also talking about El Nino, La Nina, that sort of thing. So I'm gonna gloss over some of that stuff just to give you an idea of what, and I'm by no means a tropical weather expert at all. I understand what they're looking at, but I don't sit there and spend hours and days and months poring over this data. So I just wanted to give you an idea of what they're going to be looking at or what they've been looking at over the last couple of months since May. Okay, so there's this accumulated cyclone energy index, which this ACE or ACE index that is looked at is basically, and I stated it there, is a measure of overall season activity, accounting for the combined intensity and duration of tropical storms and hurricanes. So basically, there's it's an index that is measured by activity. There's a lot kind of thrown into it to come up with that percentage, but looking at the graph here, you can see going all the way back to 1950, you could see when this ACE index or ACE index was above normal, or above like 100%. And it's basically above that yellow bar, that yellow line. The years that it was into that red category where it was above normal and pretty active, we had very active seasons. And from 1950 to 1970 was a fairly active period. Then things sort of dropped off for about 20 to 25 years, from the 70s all the way into the early to mid 90s. And then things picked back up again in the mid 90s, basically to the current time. And if you look back, like 2005 was a very active year where we went into the Greek alphabet for named storms, because we had so many. I think we had over 27 or 28 of them. This past May, early this year, the ACE was between 110 and 190% of normal. So that's where that red bar kind of is shown there for 2020. So the ACE index was running above normal earlier this year, which was one of the factors that points to a higher, a more active and higher than normal, potential higher than normal tropical season in the Atlantic Basin. So again, NOAA looked at this and said, okay, above normal season, basically that ACE is greater than 120%, and that's where it stood back in May. Anything over 165%, which is where some of this past May, where that range sort of existed, could be looking at an extremely active season. So anyway, didn't want to belabor this, but just wanted to show you this is one of the factors that was thrown into the outlook that was issued back in May by NOAA. Okay, so I've already kind of talked about that. We've kind of remained in this high activity period since the mid 90s. and you can see the number of years where the ACE index was above normal. Okay. What's another factor that could contribute to active inactive season? Well, sea surface temperatures in the, I'm not talking about the El Nino, La Nina regions in the Pacific, just in that MDR, that main development region in the Atlantic Basin. Going back, I'm not showing the April to May timeframe, but back in April and May, the sea surface temperature anomalies were above normal. And basically over the last month, from the end of June to just the end of July, that 4-week period or 1 month period, they're running about a ½ degree to 1 degree above average as well. So since April, basically the summary of this graphic is that the sea surface temperatures in that main development region of the Atlantic Basin have been running about a ½ degree to 1 degree above average, which is, sea surface temperatures in the Atlantic for any tropical system, I should say, they really fuel off of the water temperatures. And so if they're running above normal, obviously you would think that not necessarily relate to more active season, but potentially one of these systems could become pretty significant and strong if given the right conditions. But the sea surface temperatures in the Atlantic in that MDR region are ripe for development. So looking back a couple of months ago, some of the longer range models that predict sea surface temperatures in that MDR region for August, September, and October, basically the longer range models, and these are models that are looking from month to month, not necessarily day to day, but month to month kind of anomalies with the water temperatures. So the climate forecast system, the CFS, and then the North American Multi-Model Ensemble, the NMME, both longer range ensemble models were showing neutral to La Nina conditions in the equatorial Pacific region, which I'll get into to talk about just a second. And then in the MDR region, that main development region in the Atlantic Basin, they are showing continued warmer than normal sea surface temperatures. So those are really big keys to predicting what may happen throughout the outlook, or throughout the Atlantic Basin tropical season over the next couple of months. So let's get into talking just real briefly about El Nino and La Nina. So where are we at right now? You can see that observed in this past, basically last month, the observed sea surface temperatures in those equatorial Pacific regions that make up ENSO was running about a little bit below normal, so about 0.4 degrees below average, and that would be considered neutral. Anything plus or minus 0.5 degrees for ENSO is considered neutral. Now, if you get above a ½ degree, that's considered El Nino in the Pacific region there, but several Pacific regions that are where the water temperatures are measured. And then anything cooler than 0.5 degrees is considered a La Nina phase. So we are sitting in a neutral phase right now, but if you look at where we're at and where some of these models are taking us, at least taking the predicted sea surface temperatures out there in the Pacific for ENSO, we're going to continue to run almost every model is at least going to run neutral during the rest of the hurricane season, basically through the end of November into early December. But there are a few models that are actually taking us into a weak or even a moderate La Nina phase as we head through the rest of the summer into the fall and into the early winter months. So what does that all mean for the Atlantic hurricane season? Well, for neutral or La Nina phases in the Pacific, for the Atlantic Caribbean Basin hurricane season, this usually, what it means is it usually translates to weaker vertical wind shear. Many of you know what vertical wind shear is and how it sort of relates to like severe weather and tornadoes. But the same thing can sort of be applied to tropical systems. Tropical storms, sort of opposite from tornadoes. Tornadoes love strong vertical wind shear. Tropical systems can't stand it because what it does is it tends to rip up the storm and create a little bit more of a disorganization for these tropical systems when there's stronger vertical wind shear. Now, when The winds are relatively light aloft. The tropical systems feed off of that. They love that. So with neutral and La Nina phases in the Pacific with ENSO usually translates to weaker vertical wind shear. It doesn't mean that every day there's going to be weak vertical wind shear in the Atlantic Basin, but typically looking over a period of weeks or months, the wind shear aloft is fairly weak in neutral and La Nina phases. So that would favor an increase in tropical storm development, which I've already talked about. Now, the opposite for El Nino situations, the opposite results, usually with stronger vertical wind shear in the Atlantic Basin, which typically favors a lower tropical storm development, lower activity because of the higher wind shear. Okay, so looking back since 1965, how many neutral ENSO seasons have we actually seen? There's been 17 of them, and 13 were basically above average with respect, or were average or above with respect to number of named storms, and only 4 were below normal. So that's a pretty high probability of, with neutral ENSO seasons, of seeing at least normal to above normal Atlantic Basin tropical systems or tropical activity. During those 17 neutral seasons or neutral years, the state of Georgia has been impacted by a tropical storm or a tropical system basically every year since 2001. It's a total of 11 years. So you could pretty much take it to the bank that every time we have at least a neutral ENSO season, some tropical system has impacted the state of Georgia, which is pretty impressive looking at a total of 11 years. When was the last neutral season, you ask? Well, actually, it was last year. We were in a neutral phase of ENSO heading into the summer, and we ended up for the season last year, we had 18 named storms, 6 hurricanes, and 3 major hurricanes. And of course, probably the big one that we really dodged a bullet, but not if you were in the Bahamas, was Dorian. And Dorian became a Category 5. As it tracked across the northern Bahamas and then up the coast. So that was a pretty significant event. What about La Nina seasons? Well, looking back since 1965, there's been 17 neutral seasons or neutral years during the Atlantic Basin or Atlantic hurricane season, and then there's been 16 La Nina seasons, and of those 16, 11 of those seasons were above average activity in the Atlantic Basin, and the other 5 were average or below. So the majority of La Nina seasons were above normal, and the state of Georgia felt some impact from a tropical system 11 out of those 16 La Nina years. So even if there was a below normal year for tropical development in the Atlantic Basin, Georgia still was impacted 11 out of those 16 seasons, and that's pretty high, as you can imagine. So just to sort of summarize this slide, looking at neutral and or La Nina phases in the Pacific, which is where we're at right now and where we could be continuing as we head through the rest of the Atlantic Basin tropical season. The chances of seeing above normal activity are pretty high, and the chances of Georgia being impacted by some sort of tropical system, and even if it just brushes the coast, are pretty high, pretty significant as well. All right, so the end result, again, we looked at that ACE index, we looked at sea surface temperatures, we looked at and how ENSO can result in higher or weaker or stronger vertical wind shear in the Atlantic Basin. So all of the things that we're looking at right now, where we are, where we're potentially heading, point to a pretty active season, which we've already seen to this point. So there's no surprise really there. So in that MDR region, above the above average sea surface temperatures and the potentially weaker vertical wind shear in that development region points to a pretty, things kind of getting active over the next few weeks. So that's sort of a quick look at where we're going, or where we are and where we're going with the Atlantic Basin tropical season. As we head, we're not even into our peak months just yet, but as we head through August and certainly into September, things look like they could be, continuing to stay active And hopefully, as far as looking at, we really haven't had a major hurricane yet. It's really rare to get a major hurricane this early in the season. But a lot of things are pointing to, hurricanes and major hurricanes developing over the next, 4 to 6 weeks. And then as we head into September and into October. So earlier I mentioned NOAA released their numbers back in May, and you can see that the 13 to 19 names from NOAA's range. This is going to be updated in a couple of weeks, if not sooner, usually the first week of August. Around August 9th or 10th, I think that's when they're going to sort of take a look at things and release numbers. But back in May, they were looking at 13 to 19 named storms, 6 to 10 hurricanes, and 3 to 6 potentially major hurricanes of those 6 to 10. State University channel, we're going to be as well, so no surprise there. And then you can see the 30 average is 12 named storms, a little over 6 hurricanes, and almost 3 major hurricanes. So far, definitely looking at above normal activity for the overall forecast. Changes are expected in the ENSO neutral to weak La Nina ENSO pattern as we head through the rest of the summer and into the early fall months. And then I noted already, actually should change that to 9 named storms. I did this the other night, and Isaias, which I'm probably going to mispronounce that. The most recent named tropical storm was named by the National Hurricane Center, I think early this morning. So we now have 9 named storms through July 30th, which is today. And that is the most named storms this early in the season on record. So Isaias, I'm not pronouncing that right. Forgive me for that. But that is now crossed off the list. The next name system will be Josephine, a little bit easier to pronounce, and then you can see the rest of the list through W. Let's start with W. And many of you know, we on a local level, we certainly take what the National Hurricane Center is putting out there and sort of fine tune it for our local partners and their needs. But as far as the forecast and watches and warnings that go out, the National Hurricane Center is the primary source of that, and they do a fantastic job in identifying these systems, these disturbances, and then working with the aircraft recon that go out there to measure the instrumentation, the weather information in these systems, to then come up with the determine when they're going to become tropical systems, and then put the forecast together for the track over the next over the 5-day period. So put the website up there for the National Hurricane Center. Hopefully, I'm sure many of you are familiar with this already. Gone to their page quite a bit. The graphics, including the probabilistic, like winds, the tropical storm probabilities, tropical storm force winds, hurricane force winds probabilities, the arrival time, like the earliest reasonable time of arrival for tropical storm force winds, as well as the most reasonable time of arrival for these winds. And then there's storm surge and many other tropical weather related impacts or threats and impacts that are tied to these systems, that the Hurricane Center does a very good job sharing that information and those forecasts with everybody else. All right, so I'm going to move on. Joe, I didn't know if you wanted me to open up some questions about the tropical stuff or just wait to the very end. I'm open to either way.
Yeah, if we can while we're on the tropical system, if we have questions from the audience, that would be this would be a good time to answer those.
Yeah, sounds good. Thanks.
So if you have questions, you can either put them in chat, or since we have a smaller group today, you can just go ahead and ask. All right, so David, I'll ask a quick question. So
Sure.
we watch the news, we look at the hurricane models, and there's a bunch of models. And you know, the last few hurricanes, we've seen that revised a couple times. Is that modeling system getting better? Are they taking more factors into account? Because it just could be perspective, but it looks like there's quite a bit of revision from their initial estimates.
Yeah, good question, Joe. To answer your question about are the models getting better, yes, they definitely are. If you ever look at the cone, the forecast cone, that is basically that cone is basically saying, looking at telling you that there's a 2 in 3 chance, or about a 67% chance that the storm is going to remain within that forecast cone over the next 5-day period. And if you look at how that cone has sort of shrunk over time, going back maybe 10, 15 years ago to where we are today, that forecast cone has really shrunk in size. And a lot of that is because of how well the models are doing or have done over the last couple of years. And the models continue to get better with more high resolution data, variables that are being inputted and ingested into these models to begin with. So a lot of times we don't just look, and the Hurricane Center doesn't just look at one model. I know you all have heard of when somebody says like the spaghetti plots, they're usually referring to an ensemble of models. And it's not just, it could be 10 different models, or it could be 10 different solutions of one model that we look at. Now, a lot of times, if you're watching like local news, they're not going to show the 10 or 20 different solutions of one model. They're going to show 10 different models that are out there. And a lot of times it can be a little confusing, but the ensembles, the nice thing about when you look at ensemble modeling is it's one model. It could be the European model that's tweaked for sea surface temperatures or vertical wind shear or climatology, and just making those slight adjustments with that one model can result in 50 different solutions. And I think that's what's getting better and better over time, is those ensembles, those variables that are getting ingested into the initialization of these different model runs are getting better and better. And the satellite data that we have, and the radar data that we have, and the upper air data that we have, all ingested into these models. And that data is becoming is getting really good and becoming better and better as each year goes by as well. So I hope that sort of helps answer your question. That is the modeling perfect? No, it never will be. But is it getting better and allowing us to really pinpoint how these tropical systems, where they're going, how they're going to intensify or detensify? I mean, the biggest challenge with models today, if you talk with the National Hurricane Center meteorologist, is models are still struggling, not so much with the direction and speed of where these systems go, but whether or not they're going to intensify, and how strong they're going to get, how quickly they're going to get. That's where the model is time with, and we've seen that over the last couple of years with like Michael. None of the models predicted Michael to become a Category 4, high-end 4 or low-end Category 5 just before making landfall of the Florida Panhandle a couple of years ago. So
yeah, that's the one that stands out in my mind as we look at models. Yeah,
for sure. So I hope that helped. I'm sorry to be long-winded on that response, but I hope that helped to answer your question.
Yep, that's what I was looking for. And just one more quick follow-up: are we out of the, so to speak, the danger period for Gulf or Caribbean formed tropical storms? Or is that our early or mid part of the hurricane season typically?
Yeah, as far as initial development, you can still get, like, I wouldn't say we're quite out of that, period of the season just yet. As we head through August and September, can we get just an initial development in the Gulf of Mexico? Certainly, but as we go through the heart of the tropical season, a lot of the systems that get into the Gulf usually originate in that main development region of the Atlantic Basin, which is farther out, off the Cape Verde Islands of Africa, and then all the way across the Atlantic Basin there, heading toward the Caribbean. So I wouldn't say it won't happen, but as we head into August and September, it's less and less likely to get a system developed straight out of the Gulf of Mexico initially.
Okay.
Yeah.
Appreciate it. Any other questions from the group?
This is Edwin. I have a question.
Hey, Edwin.
Hey, Dave. Appreciate you being here with us tonight and doing this presentation. Something, Dave, I ask Will occasionally, and I'm just going to throw this out there. This is going to be a piece for National Hurricane Center and the forecasting side, and also relates to the more tornadoes, severe weather. So this is going to be a double take, and I know I'm a little ahead of the ball game, but I'm going to ask it all at one time. The question I get asked the most, when people and volunteers are wanting to help, doing storm spotting and doing relaying and things of that nature, is there a certain type of software that I have people all from every time there's a storm, a severe storm that people are working, they say, well, what software would you like me to monitor? What is there a specific software that you want? And I always say no. I mean, monitor National Weather Service and whatever you may have. But I wanted to get your opinion, like on HRVAC software versus, like maybe Storm Lab or like 2.0 or something like that, or GR level 3 or X, or with all the little different add-ons. I know people have those things, and in your opinion, are those good tools to have in the toolbox, and should I encourage those to be used?
Yeah, that's a great question, Edwin. I think HRVAC is really good, and they've updated, the software just recently, just this past year, where you can like register for it online. It's a little bit different than I think in the past, where you had to like sort of download some software. But HRVAC is really good for it really depends what you're monitoring, but obviously for tropical related systems, tropical weather, HRVAC is great. We use it in our office, and sometimes we'll, at the SOC, if I'm deployed there or one of us is deployed there, we always show like HRVAC type stuff, and I know you guys probably do that at GEMA quite a bit. As far as,
can you put those software packages or links in the chat as well, so everyone will have the opportunity to go look at them?
Yeah, I'll definitely dig it up and find it for you. I don't have the link off the top of my head, but I could definitely look online and check it out for you, Joe. No problem.
Okay, thank you.
Let's see here. But for like just general radar, monitoring and interrogation, you mentioned, Edwin, you mentioned like GR level 2, and that's a really good software. I think it's just a one-time GR level X data software. I think it's like $250 if I'm not mistaken. And I encourage that with a lot of our county and local partners to, if they don't have some sort of like third-party software that's already providing them radar data into their operations.
Excellent. All right. Well, I think that's what I was looking for, and we appreciate that information.
Yeah. Let me dig up her. You can HRVAC.
I think they put it in the chat. HRVAC.com.
Yeah, there it is right there. Yeah, a lot of this stuff you can Google search for, but yeah, it's just HRVAC.com there. Let's see here. The GR level 2, if you search for that, it'll provide you the website there too. But at the end of the presentation, I'm happy to go back and just double check and make sure everybody's got what they needed with respect to some of these tools and resources. All right. Any other questions related to tropical stuff? And at the end here, certainly we can circle back and talk more about the tropical stuff. Okay. I don't know. I just kind of picked out a few things. I know you guys, this group seems to be, really aware of severe weather activities and reporting and training. So I didn't want to get into the weeds. I did want to show you a few things. I'm sure a lot of you follow the Storm Prediction Center. They put out some really cool real-time graphics. And I wanted to share a few things with you related primarily to tornadoes. This does not account for hail and wind reports, but these are looking back basically through July 28th this year. These are the number of, many of you are familiar with local storm reports that the National Weather Service forecast offices will push out. And a lot of it comes from obviously the spotter reports that we get from you all, from emergency managers, from the media. But this is just looking at the number of tornado reports. This does not have anything to do with actual confirmed tornadoes, but just preliminary tornado LSR, local storm reports that go out across the entire country. Basically, through July 28th, there was 953 tornado LSRs that have been transmitted. And again, some of these, this does not translate to the number of actual tornadoes, because one tornado that could be on the ground for like 20 miles may garner like 40 to 50 storm reports. So keep that in mind. But anyway, I want to show you where we sort of stack up this year compared to sort of the average annual trend from 2005 to 2015, sort of like a 10-year average. So basically, that number above the 953, the 1104, is that 10-year average. So we're actually running, to this point, we're running a little bit below normal with respect to preliminary tornado reports across the country. You can see where the busier months are. Basically, this year, as we ramp up through March, April, May, and into June, that's where our busiest and most active time of year across the country is, from the south all the way into the Midwest, the plains, and the upper Midwest regions. So even though the sort of the severe weather regions, or the peak in the severe weather seasons shifts from the south in the early part of the year to the Midwest and the upper plains as we head into the summer months, you can see this gives us a representation of how the whole entire year has been so far, at least with respect to tornadoes. So I wanted to compare that to 2019, looking back the past few years, where we were at last year, at the end of the year, 1,676 total tornado reports. Again, not actual tornadoes themselves, but tornado reports. And that was well above the average of 1,402 for the season. So we were running above normal with preliminary reports on tornadoes last year. And you can see we had a very active April and May, and then even into June, and then things sort of tailed off a little bit, but then picked back up a little bit with an event back in October. And again, this is for the entire country, not just for the South or the state of Georgia. So what about, so we were above that 10-year average with tornado reports last year. What about 2018? 2018, we were below normal. You can see we ended up about 1,169 reports compared to that 1,402 10-year average. Let you look at that there for a second. But then in 2017, we were above normal with 1,522 total tornado reports. 2016, back down below normal. So you see we've kind of gone, one year's been above normal, the next year's been below normal, the next year has been above normal. So there's really no rhyme or reason to any of this. I just thought it was kind of interesting to show. So if everybody can see that, this is looking back basically since 2005 all the way through 2020, or basically through this current year, through July 28th, which is the dark red line that you see that ends just the other day. The mean is that black line. We're just below the mean, but you can see all the other years that are plotted basically since 2005. And what I did is the highest year with tornado reports, and this was definitely the highest year with actual tornadoes, was back in 2011. No surprise there with the super tornado outbreak of April 27th and 28th that impacted parts of Mississippi, Alabama, Tennessee, and even Georgia. We had record number of tornadoes that season. That was also the same year that Joplin got hit in Southwest Missouri. So it was a very, very active tornado and severe weather season that year. 2008 was another very active year. But then even last year, 2019 was fairly active. The third, just looking at tornado local storm reports, is the third most active season was last year since 2005. And then if you look at the lower seasons, or the years where we had pretty low tornado numbers, 2013 stands out. That's the lowest. And then some of the other years were like 2012 and 2015. 2016. So where we go from now, we'll probably end up somewhere in the middle, unless we have like a crazy outbreak, sometime in the fall or early winter year this year. But anyway, I just thought this was interesting, just to show how all these reports, a bunch of them get transmitted. You can see back in 2011, we had 2,240 tornado storm reports be transmitted. And a lot of that came from folks like you guys that are not only amateur radio operators, but also trained in spotter techniques and spotter training, Skywarn. So that is, wanted to share that with you all. And where we are, let's see here. Okay, so I know this is always kind of a topic of discussion amongst weather enthusiasts. Are tornadoes becoming more frequent, and are they becoming more violent? Well, basically, since records have been kept, which dates back to like the mid 1800s, violent tornadoes have occurred. And I shared this link, and I can, let me click on this link real fast. This is from the Storm Prediction Center, and I can put this link in chat as well. Let me see here. If you go to this link, this is basically looking at, it breaks down all the different real significant tornado outbreaks going way back to the 1800s. So I'm going to scroll over here. So if you look at the right of my page here, you see 1900 to 1924. And for the record, the March 18th, 1925 tri-state tornado to this day is the longest track tornado on record, which I think is about 215 miles that there was continuous damage from that particular tornado. And it went across 3 states. That's why they call it the tri-state tornado. But you can see there's a lot of information going to the 1800s. So my point in showing you all this, I'll go back to my presentation. Go back. We've had violent, tornadoes for a very long time, as long as we could keep track of them and record them through some sort of print archive. So now, what about the frequency of tornadoes? Now, certainly, if I had more time, I really wanted to show you guys the number of actual tornadoes across the state in the region going back to like 1950, but I didn't have time to do that, and I apologize for that. But I will say this is based off of experience and, working for 21 years in the Weather Service, obviously working through like the April 27, 2011 outbreak when I was in Huntsville. The frequency of tornadoes can be directly related to technology and population density, as well as education and awareness. So what I mean by all that is look at how far like our radar technology has come since the 70s and into the 80s, going from the old C-band radars to like the military radars to the Doppler radars in the 80s, and now we're able to incorporate dual pol with the dual polarization with the radars that we've had since about 2011, 2012. Look at cell phone technology. Look at just the ability to capture and report a lot of these events. Look at the way the populations have grown in tornado-prone areas, like even in the southeast regions. So you have more people living in areas that get hit by tornadoes. Naturally, you would think that the numbers are going to go up just because they're being reported. The damages are being reported. The pictures and the videos are being taken because of cell phone technology and how you don't need like these really cool cameras to take videos and pictures of these things anymore. So I know it sounds really basic and simple, but we've definitely seen an increase in tornadoes because of, you can definitely attribute it to climate patterns and global patterns and stuff like that. But in addition to that, you have to look at these things that have advanced in technology, both on the meteorological side and with respect to technological advances with cell phone and cameras, and just the population density in itself being higher in areas that are tornado prone throughout the year. So anyway, that was just the thoughts according to Dave over the last, just kind of looking back at the numbers with frequency. And as far as the violent nature of tornadoes, we had the 2011 outbreak, which was, we had 8 violent tornadoes in an 18-hour window, which is unheard of. To have 8 EF4 and EF5 tornadoes basically in less than 24 hours, a small portion of the United States. Usually, we may go 3 or 4 years without ever seeing an EF5 tornado, and to experience a handful of those in one day is unprecedented. But they can happen, and doesn't mean it's going to happen every year. But we always say, when we do training, that we have to be prepared for these violent tornadoes, because they're the ones that typically result in the highest number of fatalities and injuries. Okay, so transitioning a little bit, this is more of a reiteration of how important it is to have groups and people like you that dedicate, volunteer their time basically to get us storm reports. Real-time reports are an essential part of our warning decision-making process. Just whether you're in chat or just feeding us the information through amateur radio operations or through online web services, it's extremely important to our warning decision making, because it really helps us. If we're on the fence with a storm, it really allows us to have more confidence in what really is happening out there in the field, and that ground truth, and you hear the ground truth, and having the eyes in the sky, the eyes toward the sky is extremely important, as long as you're doing it in a, we never want anyone to jeopardize or put themselves in harm's way to get it's just not worth it at all. But providing this information gives us verification with our warnings. It assists emergency managers with awareness and response to damage areas. It contributes to official storm data and the NCDC records, which is the National Climatic Data Center, which is where official storm data is archived. And of course, there's a variety of different methods of reporting that I don't need to really expound too much with this group. Techniques, again, I feel like I'm preaching to the choir here, guys, so I apologize, but location, knowing that we can dive into like Google Earth or Google Maps and type up an intersection and get a specific lat long is really helpful these days, compared to where mapping was like 10 or 15 years ago. Things have very much changed, and they're a lot better for us. So being as specific as possible, you can do that now, because we can just punch it in real quickly into our systems and come up with exactly where the location of the event was, or the damage, whatever it is that you're reporting. The time of the event is really important, not necessarily the time of the report. When we're looking at wind damage for trees that are snapped, uprooted, mainly when we talk to the general public about this, we really, anytime some branches fall, people may report that as trees being snapped. But obviously we want to know what's the extent and the severity of these trees being snapped. How many? How large were the trees? Was it just branches? That really helps us in trying to estimate how strong the winds were in that particular event. So again, preaching to the choir here, but these are things that we continue to reiterate to the general public and to a lot of the people that attend our responder training classes. Hail reports, largest hailstone safely. We try to reiterate to avoid saying that you had marble size hail, because that can fluctuate on sizes, and instead just relate relate to something, an object that is uniformly understood, like golf ball, baseball, quarters, nickels, something that doesn't really change size from one region of the country to another. So those are things that we definitely try to, pass down to everybody when we talk about proper reporting techniques. All right, that's all I had, guys. I did not want to get into, especially with this very intelligent group of trained spotters, I didn't want to get into any of the weeds with spotter training. So I will leave it at that and open it up. I make it as interactive as possible. And once again, I really appreciate the time to just be here this evening and talk with you guys.
All right, we'll go ahead and open this up for questions from the group. I do want to start this off with one that that I've been thinking about since my storm spotter training back in the day, and that's the issue you have with the radar ground height as you go further northeast in Georgia from Peachtree City.
Mm-hmm.
And it just seemed to me as I looked at the map and seen how that worked out that there was almost a blind spot in the northeast Georgia area that, but from between Peachtree City and South Carolina radars. Is that still an issue?
Yeah, Joe, it's still an issue. I wouldn't say it's necessarily a blind spot. I mean, we could still see storms that form up in that area, but definitely when you get up into like Lumpkin, White County, Towns, Union County, Fannin, that area it's tough for us sometimes to really get and see the resolution of, at least in the low levels, like you were saying, of the storm just off the surface because of how far away those areas are from the Peachtree City radar, or even from the Greenville-Spartanburg, South Carolina radar.
Okay, and that makes storm spotting all that much more important in those areas as well, right?
Oh, for sure. And I was going to add that one of the things Greenville-Spartanburg has done to try to mitigate some of these blind spot issues is they've found a way to drop the 0.5 degree angle a little bit lower to like 0.3 or 0.2, so that they can see a little bit better farther out away from where the storms are, farther out away from the radar. And we're going to try Peachtree City. We're going to look into that. It's a software upgrade and build that needs to be installed, and it takes some time. I don't think there's necessarily any downtime to the radar, but it does take a little bit of an adjustment. And so this was just recently implemented last fall at the GSP office and for their radar. So we're kind of waiting to see if it's really made a dramatic or a noticeable difference in storms that are a little bit farther away for them to see. And if so, I think it's something that we're going to look into doing as well.
All right, thank you. All right, so I'll quit being the weather nerd and open it up to everyone to allow questions.
Yeah, I'm trying to look at chat too. I hope did I miss anything? I just have a really small window.
Yeah, Tom Ollie with a question.
Hey, Tom.
Can you hear me okay?
Yep.
Yeah, Tom.
Okay. I'm curious, Dave. Does Peachtree City utilize drones in their damage assessments? If so, how? Who's doing that for you?
Great question, Tom. We personally do not, we don't own any drones, but are drones used in damage assessment surveys that we do? Yes, and they are used a number, Edwin could maybe talk to this. GEMA, all the 8 regional coordinators, each of them have their own drones. So we could go through the area coordinators through GEMA, but there are a number of counties that, whether it's through their police or fire, they've purchased their own drones. And there are times where we've utilized, especially over areas where it's just hard to get to by foot or by, car or truck. It's been very helpful to see if maybe a damage path extended a little bit farther than what we were initially thinking on the ground. So yes, just to answer your question, they are definitely being utilized more and more over the last few years, and I can see that definitely continuing moving forward. Now, whether or not the actual National Weather Service offices get their own drones, it all really depends on money and how that's allocated to the field.
Yeah, you still have the licensing that has to occur as well for that. But yeah, I'm
Right.
familiar with the guys that do stuff with GaAUXCOMM. I just didn't know how National Weather Service had used them. I was curious about that. Thanks.
Yeah, no problem. We love the drones. I think that not just getting up into areas where it might be harder to get through a vehicle on the ground, but also for more significant damage, like we're talking EF2, EF3, or even greater damage. Getting that drone footage. I mean, I've been up in helicopters a bunch of times to see some of the more significant damage from the air. But the drones allow you, helicopters can only get so low. The drones allow you to get really up close and see some of this damage from the air. So that kind of high resolution data that we can sort of stream or feed and look at is really, really beneficial to our damage assessment, surveys that we do post event.
So to speak a little more about drones and drone use and doing survey mapping, there's several counties, more so the larger counties, have specific software packages that they can load from their GIS platform and their databases that they keep with addressing and taxes and different things of that nature. And they can go through and pretty much fly an area. And Dave, correct me if I'm wrong, but they can pretty much get a pretty close dollar figure to see how much damage has actually occurred within a matter of a couple of hours, where things used to take or could take up a several days or weeks.
WA4AS repeater.
Yeah, great point, Edwin. The GIS capabilities are unbelievable these days, and I am not a GIS expert myself, but I've watched and been around a lot of these folks that are into that, and it is unbelievable how they can utilize the graphics and the mapping to come up with these, these post-event, post-storm damage assessments for their counties and their areas.
Awesome.
I was
Any
gonna.
more go ahead.
No, Joe, you're fine. I want to make sure everybody got my email address. I think there was a question in chat about possibly presenting to a local group, and I have no problem doing that if we can make it work. Go ahead and just email me. If anybody had any other questions, you could always email me about that stuff. But if you wanted a little presentation here and there, I'll see what I can do to help you all out anytime. Because we really appreciate all that you guys do to support us and help us out. So we consider that definitely a good two-way street.
And so, David, with COVID, did you guys switch to all online storm spotter classes?
We're going to, Joe. I just sent a note out to our staff the other day about working on a virtual class or just updating our presentation to make it a little bit more interactive, because we're going to end up having to go virtual through the fall months. Hopefully, as we go into 2021, things will improve a little bit where we can get back out there in person. But definitely for the rest of this year, when we start, spotter classes back up sometime after like Labor Day in September, those will be virtual with the counties.
Yeah, I think with the technology, that'll make it much easier and a little more inclusive, right? As opposed to some smaller venues and.
Exactly. I love the in-person classes. There's obviously, you can't replace that sort of interaction, but I think I've been wanting to do some virtual classes anyway over the last few years, because I think it allows more people to kind of, join from home, or, and it just gives everybody a little bit more flexibility to attend these classes in certain areas. So I'm looking forward to it to some degree.
All right, any other questions from the group? All right, well, we want to thank you, David, for your time. Certainly appreciate you coming, and we'll get the links sent out to everyone that attended tonight to make sure everyone has the opportunity to see those. So thank you again for coming. Our next training class will be August 27th, and that'll be DRATs. We're going to talk about DRATs, so watch our Facebook and GaAUXCOMM and their newsletter for the invites to that one. And here's some more information on AUXCOMM and where you can reach us through our many social media outlets: Facebook, Twitter, Instagram, our YouTube channel where this will be posted, our actual website, and GaAUXCOMM page. So I'll leave this up for a second if you want to copy any of those down. And outside of that, we'll close the meeting out this evening and thank everybody for their attendance, and especially David. Thank you for again for presenting to the group.
My pleasure. Thank you, Joe.
Yeah, great presentation, Dave. Really appreciate the details that you offered there.